This video will cover beginner part 1 questions regarding the topic of derivatives inverse trigonometric functions. First, let's see why these formulas came out. I will prove it from arc sine of x. Y equals sine of x is not 1-to-1. Using the horizontal line test, you will see more than one intersection, like this. However, y equals sine of x is 1-to-1 with this restricted domain. You can check with the horizontal line test. There is only one intersection. The graph of y equals sine x is reflected in the line y equals x. You will see the graph of y equals arc sine of x. Now this domain becomes the range. Now this range becomes the domain. Let y equals arc sine of x, then sine of y equals sine of arc sine of x. We can rewrite as sine of y equals x, differentiating both sides of the equation with respect to x regarding y as a function of x. Cosine y times y prime equals 1, then y prime equals 1 over cosine of y. Using the trigonometric identity, sine squared y plus cosine squared y equals 1, then cosine squared y equals 1 minus sine squared y, then cosine of y equals plus minus square root of 1 minus sine squared y, but the range is minus pi over 2 to pi over 2. Then cosine of y is always greater than equal to 0. So cosine y equals square root of 1 minus sine y squared. Back to the original, then 1 over square root of 1 minus sine y squared equals 1 over square root of 1 minus sine y is x, so we can rewrite as x squared. The denominator 1 minus x squared cannot be 0. That means x squared cannot be 1. X cannot be plus minus 1. Now domain is minus 1 to 1 and range is minus pi over 2 to pi over 2. Therefore d dx of arc sine of x equals 1 over square root of 1 minus x squared. Then x is greater than minus 1, then less than 1. Now we know d dx of arc sine of x equals 1 over square root of 1 minus x squared. Remember when you learn the chain rule, everything is the same. The only difference is that it uses inverse sine function. Question 1 is 1 over square root of 1 minus 4x squared times 4x prime equals 1 over square root of 1 minus 16x squared times 4. Final answer is 4 over square root of 1 minus 16x squared. Or let y equals arc sine of 4x and 4x equals u. Then you can rewrite as y equals arc sine of u. Then dy dx equals dy du times du dx equals dy du is 1 over square root of 1 minus u squared times dy du equals, from here is 4. Then 1 over square root of 1 minus u is 4x. 4x squared equals 16x squared times 4. The final answer is 4 over square root of 1 minus 16x squared. we have the same answer. So you can think of it as when y equals arc sine of u, then y prime equals 1 over square root of 1 minus u squared times u prime. Question 2. d dx of arc sine of x equals 1 over square root of 1 minus x squared. Then d dx of arc sine of u equals, use the chain rule, 1 over square root of 1 minus u squared times u prime. Think of it as d dx of arc sine of u equals 1 over square root of 1 minus u squared, the inner function u is x squared, times u prime, the inner function is x squared, equals 1 over square root of 1 minus x to the power of 4 times 2x. The final answer is 2x over square root of 1 minus x to the power of 4. Question 3. Think of it as d dx of arc sine of u equals 1 over square root of 1 minus u squared times u prime equals 1 over square root of 1 minus square root of x squared times square root of x prime equals 1 over square root of 1 minus x times square root of x prime is, as we know, 1 over 2 square root of x, or square root of x prime equals x to the power of 1 over 2 prime is 1 over 2 x to the power of minus 1 over 2, then 1 over 2 times back to the radical form, then 2 square root of x, then 1 over 2 square root of x times square root of 1 minus x, or we can rewrite as 1 over 2 square root of x minus x squared. Shall we prove arc cosine of x now? Y equals cosine of x is not 1 to 1. The restricted cosine function with this domain is 1 to 1. The graph of y equals cosine of x is reflected in the line y equals x. You will see the graph of y equals arc cosine of x. Now this domain becomes the range, this range becomes the domain. Let y equals arc cosine of x, then y equals arc cosine of x, cosine of y equals cosine of arc cosine of x. Then we can rewrite as cosine y equals x. Differentiating both sides of the equation with respect to x, regarding y as a function of x, then y prime equals 1 over minus sine of y. Using the trigonometric identity, sine squared y plus cosine squared y equals 1, then sine squared y equals 1 minus cosine squared y, then sine of y equals square root of 1 minus cosine squared y, or minus square root of 1 minus cosine squared y. The range is 0 to pi. That means sine of y is always greater than equal to 0. So sine of y is always positive. But now, sine of y, the denominator never be 0. That means y is between 0 to pi. Then x is changed minus 1 to 1. Then back to the original, minus 1 over square root of 1 minus cosine squared y equals minus 1 over square root of 1 minus cosine of y equals x squared. Therefore, d dx of arc cosine of x equals minus 1 over square root of 1 minus x squared. Then domain x is between minus 1 to 1. Now we know d dx of arc cosine of x equals minus 1 over square root of 1 minus x squared. Then think of it as d dx of arc cosine of u equals minus 1 over square root of 1 minus u squared times u prime. Question 4 is minus 1 over square root of 1 minus x over 3 squared times x over 3 prime equals minus 1 over square root of 1 minus x squared over 9 times 1 over 3 equals minus 1 over 3 times square root of 1 minus x squared over 9 equals minus 1 over square root of 9 times 1 minus x squared over 9 equals minus 1 over square root of expand 9 minus x squared. That is the final answer. Question 5. Think of it as d dx of arc cosine of u equals minus 1 over square root of 1 minus u squared times u prime. Back to the original equals minus 1 over square root of 1 minus u part is tangent of x squared times tangent of x prime equals minus 1 over square root of 1 minus tangent square root of x times secant squared x equals minus secant squared of x over square root of 1 minus tangent squared x. Question 6. Think of it as d dx of u squared equals 2u times u prime. Back to the original equals 2 times arc cosine of x times arc cosine of x prime equals 2 arc cosine of x times minus 1 over square root of 1 minus x squared equals minus 2 arc cosine of x over square root of 1 minus x squared. Shall we prove arctangent of x now? Y equals tangent of x is not 1 to 1. However, the restricted tangent function with this restricted domain is 1 to 1. The graph of y equals tangent of x is reflected in the line y equals x. You will see the graph of arctangent of x. Now this domain becomes the range. This range becomes the domain. Let y equals arctangent of x. Y equals arctangent of x. Then tangent of y equals tangent of arctangent of x. Then we can rewrite as tangent y equals x. Then d dx of tangent y equals d dx of x. Secant squared y times y prime equals 1. Then y prime equals 1 over secant squared y. Using the identity, tangent squared y plus 1 equals secant squared y is from sine squared plus cosine squared equals 1. Divide by cosine squared on each side. Then tangent squared x plus 1 equals secant squared x. Then back to the original, 1 over secant squared y means 1 plus tangent squared y equals 1 over 1 plus tangent y equals x, then x squared. Therefore, d dx of arctangent x equals 1 over 1 plus x squared. Question 7. Think of it as d dx of arctangent of u equals 1 over 1 plus u squared times u prime equals 1 over 1 plus 2x plus 1 squared times 2x plus 1 prime equals 1 over 1 plus, you can expand 4x squared plus 4x plus 1 times 2 over 4x squared plus 4x plus 2. We can simplify 1 over 2x squared plus 2x plus 1. Question 8. As we know, square root of x prime equals 1 over 2 square root of x. Then d dx of square root of u equals 1 over 2 square root of u times u prime. Then this part is inner function of u, so 1 over 2 square root of u part, which is arctangent of x times arctangent of x prime equals 1 over 2 square root of arctangent of x times 1 over 1 plus x squared. Then we can rewrite as 1 over 2 square root of arctangent of x times 1 plus x squared. This is the last question. As we know, 1 over x prime equals minus 1 over x squared. Then d dx of 1 over u equals minus 1 over u squared times u prime equals minus 1 over u part squared times u part prime. The inner function is arctangent of x equals minus 1 over arctangent of x squared times 1 over 1 plus x squared. The final answer is minus 1 over 1 plus x squared times arctangent of x squared. I hope this video has been helpful. If you have any questions, leave them in a comment below, and I will address them in a future video. Thank you for watching. Please like and subscribe for more.